From zero emission perspective, the fuel cell and hydrogen is a good candidate for heavy duty mobility applications. However, the right fuel still needs the right architecture in order to deliver the best performance for all applications. So this is a typical layout of a fuel cell drive system, and I'll just walk through some of the key components. A typical fuel cell propulsion system has a fuel storage, usually in the form of some kind of a vessel, hydrogen tanks, and valving stored at pressure, and that pressure allows the hydrogen to flow to the fuel cell stack as the fuel cell supply, which is used to make electricity inside the fuel cell stack. The fuel cell power system comprises of the fuel cell stack and other components such as the air delivery system, which drives air into the fuel cell. And fuel cells are like engines in that they are air breathing and require fuel to generate electricity. So that air system will delivers the airflow into the fuel cell. There's also a cooling system. Fuel cell stacks at higher power tend to be liquid cooled and have a cooling system and a fan assembly that's used to knock the heat out of the system with a pump to drive that flow. The fuel cell is usually connected to some form of interface electronics to a high voltage bus, and that could be a DC-DC converter or some form of bridging electronics, contactors, reverse current protection, pre-charge circuitry to interface that high voltage bus. And then moving down to the rest of the drive, we have the traction inverter, which drives the traction motor and ultimately is connected to the wheels of the vehicle. Heavy duty battery system, so the high voltage battery energy storage media, which is used for recuperation and acceleration benefit as well. And of course, power electronics for driving inverters, which power the accessories on a truck. In this case, where a power takeoff was used, we're replacing power steering and air brakes with an electric drive that require an inverter for that power.